Hey students, welcome back. Today we are talking about molar conversions. So up to this point, we have learned how to do molar masses and we have learned how to do mass percent. Now we're going to use those molar masses to move us right along and convert from moles to grams, grams to moles. So here we go, molar conversions or mole conversions. First off, fill in your title up here, page 27, molar conversions, section 4.5. What is a mole and how do we use moles? So let's go ahead and answer that question on what is a mole. So a mole is an amount of substance. And what hopefully you've learned is that all our molar masses are different, right? We have different molar masses and everything has a different mass. So we can't really compare. We can't say 50 grams of carbon and compare that to 50 grams of gold because it wouldn't be the same amount of atoms. So what they did was they came up with this thing called a mole. It was actually by Avogadro. We'll get a little more information on him tomorrow when we talk about his number. But so they set all these things and they have a certain amount of particles and those are equal to 1 mole. That way we can compare apples and apples. So how we do this takes us back to when we did some dimensional analysis in the fall, early in the fall, very early in the fall, or when we talked about unit canceling. That's what we're going to do here. Remember, our equivalence statements are two units that are equal to each other. Excuse me, I got a little ahead of myself in writing. Two units that are equal to each other. And so all along, we have been labeling our molar masses as grams per mole. So that's our equivalence statement. 1 mole equals whatever that molar mass is of that substance. So our first step then has to be that we have to find the molar mass. So step A is we're going to find the molar mass. And this is something we've been practicing now for a week and a half. All right, so we're going to find molar mass. Step 2 is kind of where we're going to have to split. We have to pick, excuse me, we're going to have to decide what we're looking for. Decide what we are looking for. So if we are going to grams, we will excuse me, whoops, got a little ahead of myself. If we are going to grams, we will multiply by molar mass. And if we are going to moles, we will divide by molar mass. Okay? And we're going to put this on our T-charts just like we did earlier this year. So let's kind of revisit those. So kind of a quick review. Remember our molar mass of water, you can flip back in your notes, was 18.02 grams per mole, right? And then our molar mass of iron 2 chloride, boop, boop, was 222.75 grams per mole. All right, so let's see if we can't do this. So remember, kind of breaking it down, we're going to underline what we know. We have 250 moles. We are looking for grams. So on our T-chart, we're going to put what we underlined, the 250 moles of H2O. Make our T-chart. Can make this a little bit bigger. Hopefully we're not making you guys a little dizzy or anything. So we're going to put 1 mole of H2O on bottom. And we're going to put 18.02 grams on top. Moles cancel out then. Remember the unit canceling portion. So to solve this problem, we're going to take 250 times 18.2, which if we look up here, 2 grams multiplied by molar mass. So we're going to take 250 on our calculator. 250 times 18.02. We should get 4,505, and our label is grams. Pretty simple there, yes? Awesome. Let's see if we can't reverse this. So this time, how many moles? We're looking for moles. 794 grams of iron 2 chlorate. So we're going to start with 794 grams on our T-chart. Remember, iron 2 chlorate was Fe, parentheses ClO3, parentheses 2. All right. We're going to put the molar mass on bottom to get our grams to cancel. So we're going to put 222.75 grams of Fe parentheses ClO3 parentheses 2. And on top, we're going to put 1 mole of Fe parentheses ClO3 parentheses 2. Grams then cancel. So we're going to take 794 and divide by 222.75. We'll keep our 2 decimals there. We're going to say 3.56 moles of Fe parentheses ClO3 parentheses 2. Hopefully you're seeing how I'm doing that. If not, go ahead and hit pause, rewind, however you want to do it. All right. Remember this 222.75. If you look back in your notes a couple of days, go back to molar mass. We found that because we took just kind of a quick aside. Remember here's our formula, FeClO3, 2. We had Fe, we had 1 times 55.845. Cl, we had 2 of those times 35.4527. Then we had O, 6 times 15.9994. Right? We multiplied those out and just added them together. That was just hopefully a quick review for you if you weren't understanding where we got that number. So that molar mass is on repeat down here for this one. We have 222.75 is our molar mass because we are still talking about iron 2 chloride. So we know we have 0.108 grams. We're looking for moles again. So on our T-chart, we're going to start with 0.108 grams of our iron 2 chlorate. We'll put it on our T-chart. We need grams to be on the bottom so we can get it to cancel. Remember, this is grams per mole, so we're going to put that 222.75 grams on bottom. We'll put 1 mole on top. And we are ready. We're going to take 0.108 divided by 222.75. And we should have our answer. This is going to give us quite a few zeros here. So we're going to say 0.000 and then 48. 48 moles. And there we have it. Hopefully fairly simple. Hopefully you remember your equivalent statements. All right. See you next time.